The browser is not a good place to store secrets, and that's why we recommend an accompanying server-side application with each browser-based JavaScript or WebAssembly client application that handles authentication. That server-side application is called a backend for frontend or BFF. The Wendy's BFF NuGet packages are designed to help construct a good BFF, as you'll see in this Quickstart. The client application we will use is coded in pure JavaScript without a library or framework, but the same principle applies to all browser-based applications, including those made with Angular, React, Vue, and all applications running on WebAssembly. I'm Roland Guit for Duende Software, a company behind Identity Server. A JavaScript application running in the browser can't keep a secret. An access token, for example, is a valuable target for an attacker. We don't want to expose that to a browser because it is vulnerable to all kinds of attacks, such as cross-site scripting attacks. By instead keeping secrets on the server-side companion, the BFF, the attack surface is significantly reduced, while at the same time keeping the authentication logic in the JavaScript application as simple as possible. So how does that work? If the JavaScript application wants to log in, it simply calls an endpoint on the BFF, which is the actual client of the identity provider. The BFF then handles the login process with the identity provider using a flow to get tokens. In our examples, the claims from the identity token, as well as the access and refresh tokens, are then put in the session cookie, which is sent to the browser. At first glance, it might look if this solves nothing. After all, we still seem to send sensitive data to the browser. However, the cookie is encrypted by the BFF using ASP.NET Core data protection. And only it has the key to decrypt, so it's useless to the browser. For that reason, when the JavaScript application needs to read the user claims, it has to call an endpoint on the BFF, which requires the cookie. When this endpoint works, the JavaScript application also knows there's a valid session. If the browser application wants to call an API, it also calls an endpoint that requires the session cookie. When the API is embedded in the BFF, it can just return the data. But if the intention is to call a remote API, a reverse proxy on the BFF is used, which is configured to call a certain API, when in this case the /remote prefix is used. Before forwarding the request, it will attach the access token that can be decrypted from the cookie. The API returns the data, which is then forwarded to the browser. By the way, if with all user claims and tokens the cookie is becoming too large, or when you want to have the ability to revoke sessions, you can check out the server-side sessions feature of the BFF. Okay, let's get to it. You can find the written version and the code on these URLs. We're starting out with the situation we ended up with at the end of the ASP.NET Core and API Access Quickstart. So we already have an API, and the identity provider has a scope configured for it. The BFF will be a new client for Identity Server, so let's configure that first by copying and pasting the configuration we already had for the web client. We're changing the client ID to BFF, and it will run on localhost port 5003. Also make sure a refresh token is allowed, because the BFF will take care of automatically refreshing an access token if it has it. Also make sure it is allowed to request the API1 scope. Now add a new empty web project to the solution, which will be our BFF, and at the same time it will host the JavaScript application we're about to write. Add a NuGet package with the OpenID Connect handler as well as Duende BFF YARP. This has a dependency on the core Duende BFF package, and it adds YARP support, which stands for yet another reverse proxy. Remember, we need the reverse proxy functionality to call the remote API. Next, modify launch_settings.json. Make sure the application runs on localhost 5003. In Program CS, we add the services configuration. The BFF types are added, as well as support for remote APIs, which enables the YARP support. Authentication is configured in the way we've seen before. Note that the API and offline access scopes are requested and the tokens are saved in the session cookie. Now the middleware part. Use default files will make sure our HTML and JavaScript can be loaded later on, and use BFF will check for a header on incoming requests. More about that later. Finally, the BFF management endpoints are mapped. These include /BFF/login and /BFF/user, as well as other endpoints to log out, for instance. Now for the JavaScript application. Create the www root folder and a file index.html which contains this. There are 4 buttons with an ID, a pre-tag for results, and a reference to app.js. Let's add that file now. The first part we're adding is a log function that clears the pre-tag and then fills it with the arguments that are passed into the function. Next, add this piece of code. It will do a request to the user endpoint. That requires a valid session cookie. When it returns an HTTP status code 200, we know the user logged in. If we get a 401, then no valid cookie was present and the user did not log in. We are also putting the response inside a user claims global variable, and we display a message and everything in user claims. The request also adds a header of type xcsrf with the value 1. The BFF middleware we added earlier requires this. The reason is that when a custom header is present in a request, a course pre-flight request is forced, which is more safe than sending the result to the browser and then reject it if course policy disallows it. To enable some functionality in the JavaScript application, we add the event listeners for the buttons. Each calls a function that corresponds to its ID. Now to implement the functions. The implementation of login is very straightforward. We simply redirect to the login user endpoint. Nothing more is needed because all complexities are handled by the BFF. For logout, we need a little bit more code. To log out safely without the risk of a cross-site request forgery attack, the logout endpoint needs an anti-forgery token. The logout URL that includes the token is issued as a claim by the BFF, so it can be found in the user claims collection, and then we can just redirect to it. We'll implement the call to a local API and a remote API later. Let's first test what we got. The application correctly detects that we're not logged in, and when pressing the login button, the identity server login screen shows, and the browser is redirected back. Now we are logged in, and all claims show. When pressing log out, the end session point is successfully hit. So now that we have that working, let's work on the API implementation. A local API is an API that is implemented in the BFF. We're using a minimal API, adding a handler for a request to the program CS. It is protected with the authorize attribute. Since the cookie scheme is the default authorize scheme, it will simply check for a valid cookie. No need for access tokens here. The implementation returns a message with a username. This is the route to the handler method. The asBFF API endpoint extension method adds anti-forgery protection, and it will suppress login redirects when authentication fails, returning the correct status codes. A route to the remote API, that is in the separate project we have in the solution, is added too. All requests with relative URLs that start with /remote will be forwarded to that API, and we instruct the BFF to include a user access token with the forwarded request. Last step is to implement the JavaScript functions. For local APIs, we can just do the request to the endpoint. The session cookie will automatically be included by the browser. The response is dumped in the pre-tag. The call to the remote API is similar, and again, all complexities are handled by the BFF. /remote/identity will result in a call to /identity on the actual API. Again, for both calls, the XCSRF header is required. We're ready for a test. First log in and press the Call Local API button, which will return the message and the username. And the remote API will just return the claims in the access token. And that's it for this video. Hope it helps. See you in the next one.